Hi, welcome to BC Video 7.4a Part 1, Introduction to Arc Length. So this is the first video after Chapter 8.
Okay, so in section 7.4 there will be two things. One will be arc length and the other will be the surface area. We'll do that in the next video. So for this one we're just going to stick with arc length. So the arc length means if you were to take out a tape measure and you were to measure a piece of a curve. And what is the formula for that? So we're looking for the length of the curved segment. So if you broke it down into a whole bunch of little points and join those points with little straight segments, you can actually, all right, you can actually see that what you'd be using would be the distance formula. So what we have is a whole bunch of points all going down here. So if I take 2 points, if I call this the point x subscript I, then the one before it would be the x subscript I minus 1. Like for example, if this was x3, this would be x2, the next one would be x1, etc., etc. So the distance between these two consecutive x values would be a small quantity delta xi. So the arc length of the function between the points a, f of a, and bf of b, let me actually make this fit on the screen, would be an arc length, for some reason we use the letter S, would be approximately equal to the sum of the lengths of all these little teeny tiny segments. Well, what happens, of course, because we're looking these at actually straight segments, we'd use the distance formula between 2 points, which if you remember is the square root of x2 minus x1 squared plus y2 minus y1 squared. So in our case, that would be xi minus xi minus 1 squared plus yi minus yi minus 1 squared. Well, xi minus xi minus 1 is, of course, this quantity right here, delta xi. And yi minus 1 would be the change in y, which we would call delta y. The next step is something you would never think of doing, which is what they do is they say, okay, they leave this piece alone, and they have this piece here, delta yi squared, but then they multiply top and bottom by delta xi squared. And here's delta xi squared because the square is on the outside. What happens now is they factor out the delta xi squared, leaving them with 1 plus delta yi squared over delta xi all squared. And then I have the square root of delta xi squared, so I can pull the delta xi on the outside. And of course, another name for delta y over delta x, or dy over dx, is the derivative dy dx. And hence, your formula. Your delta xi is your dx, and your dy dx, of course, is just f prime of x under another name. And then you're adding them all together, which is where the integral comes from, and you're going to add them from x equals a to x equals b, which are the endpoints. Okay, so here's an example. So it is just a formula that you have to memorize. So as an example, let's take the parabola f of x equals x squared, and you want to find the arc length, let's say from the point 1, 1 to the point 4, 6. So how long is that curved region right there? So that would be our a, our f of a, our b, our f of b. The arc length is s equals the integral from the x-coordinate of the first point to the x-coordinate of the second point, square root of, as you can see from our formula, 1 plus the square of the derivative of the function. So if f of x is x squared, the derivative is 2x, so we'll be squaring the 2x. Now, what happens at this point, and I think I didn't go any further down, is you get the integral from 1 to 4 of the square root of 1 plus 4x squared dx. That happens to be a very ugly integrand and not one that you would be able to evaluate by hand. So very often these questions are going to be with calculator because you cannot evaluate the integral using the skills you have. Now, one thing I want to emphasize is that you could have the arc length of y equals f of x on the interval for x goes from a to b. Everything is in terms of x. The limits of integration are in terms of x. The differential is in terms of x. The function itself is in terms of x, so would be the derivative. However, you might be given a function x equals g of y. Now, in effect, they should tell you the interval from y equals c to y equals d. And of course, now everything's going to be in terms of y. So instead of from a left-hand vertical line of x equals a to a vertical line x equals b, it's going to be from a low horizontal line y equals c to a high horizontal line y equals d. Instead of f prime of x, it's going to be g prime of y. Instead of dx, it will be dy. And basically the idea is if they give you the equation in terms of y, your best bet is to leave it in terms of y. So this is like number 8 on page 485. Find the arc length of y equals x to the 4th over 8 plus 1 over 4x squared on the interval from 1 to 2. They're not very clear in your textbook that it's x equals, but if the function is given to you in terms of x, that means the interval they're going to give you is in terms of x. Vice versa, if it's x is a function of y, these will be y's. Okay, so we're going from the point 1 comma something to the point 2 comma something, and we want the arc length. So I'm just going to rewrite this as 1/4 x to the negative 2. I am going to need the derivative that's in my formula. Derivative of this is 4 times 1/8, which is 1/2 x cubed, and that'll be minus 2/4 x to the negative 3. I'm just rewriting that x to the negative 3 on the bottom to be 2x cubed. I'm ready now to plug it into my formula. The arc length is from x equals 1 to x equals 2. Square root of 1 plus the square of the derivative, which we just found right here, dx. Now I'm going to expand that derivative because not much else you can do here. So if I expand, I expand the derivative. If I expand that expression, I have the square of the first, which will be x to the 6 over 4, minus 2 times the product of the 2. So I have 2 times x cubed over 2, which is x cubed, times 1/2 x cubed. So the x cubes will cancel, you'll be left with a half. And finally, plus the square of the second term, which would be 1 plus 4x to the 6th. And of course, dx. So what you notice here is that you do have 1 minus a half. And then the next thing you might notice is we can find a common denominator of 4x to the 6. So times 2x to the 6 times 2x to the 6 times x to the 6 times x to the 6 times 1 times 1. And then if you're really observant and you rearrange this in order of decreasing exponents, you might notice, and then I'm breaking up the square root of the top over square root of the bottom. As it turns out, this is the square of x to the 6, that's the square of 1, that's double the product. So really this is x to the 6 plus 1 all squared, but I'm taking the square root of that squared. The denominator, the square root of 4x to the 6 is 2x cubed. And 6x to the 6 plus 1 is positive always. At any rate, we're going from 1 to 2. Normally you would say absolute value, but you don't need to. Oh, and I'm missing something very, very crucial in all of these steps, and I can't believe I don't have it. Whoa. You need a dx here and a dx there. Okay, so now I can get rid of the square root or the square root of the square, and now I have a polynomial over a monomial. I take each term at the top over the denominator. Whoops. And then I rewrite this as 1/2 x to the negative 3. I'm now ready to integrate. Plug in the 2, plug in the 1, subtract, and it's a whole bunch of fractions and all kinds of stuff. But it will end up being 33 over 16. And that's how long that arc